Our essential question for this chapter is, how can different fractions name the same amount? We're really going to get into that today, and our thinking about factors in multiples really kind of set the basis for this. We want to talk about equivalent fractions. We want to know if two fractions with different names, let's say 1/3 and 4/6, see how they have different names, 1/3 and 4/6, if they are equivalent, if even though they're named different things, if they're covering the same amount of space. So remember, I've told you whenever we're going to compare fractions, you need to I always say rectangles are easier than circles, but you want to make rectangles that are exactly the same length. And I think I've told you before, I like it when you stack them, because I think that makes it even more obvious. Also notice I'm using my graph paper. When I use graph paper, I can use the lines that they've given me, so I don't have to worry about me being an artist. Am I a good artist? No, we know I stink at art. I can't even draw the lines on the page. But I just went ahead, and because this is thirds, I'm like, okay, I'll do 3 big blocks. And I'm going to break those blocks into how many pieces? The denominator tells me how many pieces. 3. 3 equal pieces. The graph paper already did that for me. Now here's the thing. We're looking at 6 for the bottom. Well, we need to go into 6 equal pieces. I usually start by going in the middle because I'm breaking it into halves, and then I just have to do like 3 and 3, and that's easier to do. And if you look at my lines, that actually perfectly lines up that they're equal. 1, 2, 3, 4, 5, 6. So I have 6 6. If I had to label each of these as a unit, 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. If I would add up all my sixths, I'm going to get 6 6, which is the same as saying 1 whole. See how that's 1 whole rectangle? Now I'm going to label these. I'll use red just to keep it different. This is 1/3, this is 1/3, and this is 1/3. If I add up all those thirds, I'm going to get 3/3, which is the same as saying 1 whole, and that is 1 whole rectangle. All right, all of that is just the groundwork, where I'm like, okay, I've got my graph paper, I drew it, I've got a pretty good drawing here. My first fraction is 1/3. So how many of these sections do I color in? This tells me 1. I'm not making beautiful coloring, okay? There it is, 1/3. Now I look at my bottom fraction, 4/6. How many do I color in? 1, 2, 3, 4. 4/6 are colored in. So now I want to look and say, are these fractions equivalent? Well, let's compare. I'm going to go the end of my 1/3. Does 4/6 end right there? No, it goes all the way out here. So guess what? They are not equivalent. I can draw this on my graph paper, but the problem with drawing is that it's really hard to make drawings that are perfect. Graph paper helps me, but if I'm doing 7ths or 13ths or 14ths, it can get pretty tricky. So that is a hard way to compare, but I want to show you, if you are going to draw, use graph paper, use rectangles because it's easier to see, and make them of the same, and then you just have to work really hard at breaking them into equal parts. I want to show you another way that we can also compare these two fractions, one that you should be familiar with from last year. So hold on.